Okay, hello everyone.
Hi.
So we did our project on multiple sclerosis mediation, and the way we're going to do that is by analyzing T-cell interactions via electron, light, and scanning probe microscopy. My name is Giovanni Vignone.
My name is Wanjio.
I'm Rashid Chalapa.
So today our question would be, how can electron, light, and scanning probe microscopy be used to understand the interaction between Treg cells and cytotoxic T cells in patients with multiple sclerosis?
And can we use this information to reestablish the boundary of the immune system and to mediate or prevent further degeneration of myelin in the neurons?
So here's our abstract. The autoimmune disease multiple sclerosis causes degradation of the myelin sheath in neurons, possibly due to the deregulation of cytotoxic T cells, which ultimately results in progressive reduction of muscle function. After an analysis of the roles Treg cells play in the immune response, we propose multiple methods to mediate or even stop MS. Considering that CD4 positive, CD25 positive Treg cells can suppress the immune response, through imaging the way that these receptors actually interact with through various microscopes modalities, we can study the dysfunctional mechanism and develop a strategy to restore the integrity of these cells.
So just some brief background over multiple sclerosis. So this autoimmune disease involves the attack of myelin, which protects nerve fibers, and deterioration of connections in the central nervous system, causing a dysfunction of the peripheral nervous system. So eventually this results in permanent damage to the nervous system itself, loss of motor function or paralysis, depression, and epilepsy.
In addition to that, T cells are a type of lymphocytes, which is a white blood cell from the lymphatic system that are produced in the thymus, which is a gland between the lungs. T cells also play a central role in the immune system and mainly distinguished by other cells through their glycoproteins such as CD25 positive. In addition, cytotoxic T cells are specific type T cells that are used to eliminate virus infected cells, tumor cells, and other foreign invasive cells. Not only that, Treg cells are a specific type of cells. They actually monitor the immune response, specifically Treg cells with CD4 positive and CD25 positive receptors are in charge of stopping cytotoxic T cells from destroying other cells. Finally, T cells turn into Treg cells by going through differentiation through to transcription and translation of FOXP3 genes.
So for the current situation, through successfully performing this experiment, we could mediate or even halt progression of multiple sclerosis, which affects nearly 1 million people in the United States alone. So this number has doubled since the previous study, which was conducted around 3 years ago.
So some precedents that has been worked on by other scientists would be first, Alla and Hens in 2008 found that due to the deletion of FOXP3 in mice, which led to the reduced expression of putative suppressor genes, which is a characteristic of Treg cells, and it suggested that with FOXP3, Treg cells are able to produce faster and more efficiently. In addition to that, researcher Alla and Hens also found that mice who had EAE,
which is experimental autoimmune encephalomyelitis.
The MS version for mice, were able to prevent getting EAE after receiving Treg cells from the wild mice and the mice recovering from EAE. And finally, the suppressive ability of CD25 cells, CD25 positive cells were derived from CD25 negative cells in vitro proliferation assay. The CD25 positive cells were energic and suppressive, but the CD25 negative cells from which the CD25 positive cells were derived from proved little suppressor activity in autoimmune diseases.
Okay, so here's our project proposal. So in order to truly mediate or even halt the progression of multiple sclerosis, we must first identify the origin of the autoimmune disease. So we believe that at least for some cases of MS, this is due to T-cell interactions. So for our proposal, we're going to begin by drawing a blood sample from the lymphatic fluid in a patient with MS and one without MS, the one without acting as the control. We will then sort the cells via flow cytometry, which is a technique used to sort cells, and those cells will be Treg cells and cytotoxic T cells. Then we will compare the amount of Treg cells in a normal patient to the one with MS, And if the Treg cells are low or not present at all in the patient with MS, we think that this would be due to the FOXP3 gene, which we talked about earlier, not being expressed. That FOXP3 gene codes for proteins, which are used for the differentiation of T cells to Treg cells with CD25 positive receptors. And the way we'll tell whether this gene is being expressed is through Western blotting, which I don't have time to go into. If this is low, if the gene expression is low and there's no proteins, there's low amounts of proteins found in patients with MS, we thought we could be able to actually introduce the FOXP3 proteins into the patient with MS, or even do a blood transfusion with Treg cells. And if we do find that there's normal amounts of Treg cells, we believe that the issue could be actually with a mutation on the receptors between the Treg cells and the cytotoxic T cells. Yeah.
So for this experiment, we'll be applying the microscopic techniques we learned over the past few days, which are the cryotransmission electron microscopy, or cryo-TEM, atomic force microscopy, and confocal microscopy. So for cryo-TEM, electrons that have very small wavelengths are fired at a sample, allowing us to scan very thin segments of the organism in order to produce black and white two-dimensional images of the internal structure. So we may image the bond of the receptors between the cytotoxic and the T regulatory cells in patients who have multiple sclerosis and those who are healthy, to determine what constitutes the difference between the two types of patients, which could be a mutation. And for atomic force microscopy, we could analyze the repulsions from the electron cloud in atoms on the surface of the sample by using a thin tip probe, which is made up of like one atom, and monitoring a cantilever. We'll attach a CD25 plus T regulatory cell to a tether attached to a probe and measure the affinity between that cell and the cytotoxic T cells. And finally, for confocal microscopy, we'll produce a 3D image of T cell interactions.
Okay, and on to contributions. So from the experiments and the ideas we had, we will be able to give the science field a potential solution for MS. Another is we will approach this problem we would give this problem a different approach, which is that ever since from the start, scientists have been trying to implant T cells into EAE diagnosed mice, and we're trying a different approach where instead of injecting more Treg cells right away, we would determine the level of it first to see what is the right approach to the patient.
So our experiment is addressing those patients with multiple sclerosis using only T cells. So a challenge would be aiding the patients who have multiple sclerosis, but it's not caused by the Treg cells and they do not have mutations. So we may also encounter issues freezing the Treg cells and cytotoxic T cells with when their receptors interact, and this crystal structure may also distort the natural form of the interaction when we freeze it.
Okay, so as for the future direction, we need to actually perform the experiment to find what is the defective link between the T cell interactions. And we also need to, if that is the case, and there is an issue with the T cell interactions, then we can actually help patients with this issue with MS. And if that's not the case, then maybe look at the other causes, like is there a defect in dendritic cells presenting antigens of myelin. Okay, and here are our references, and that's it. Okay.
You guys and everybody, I guess, you're able to
So his question was, are new technologies actually allowing us to observe these interactions and the issues causing MS? So as we talked about, we were talking about using scan probe microscopy, which is a relatively new type of microscopy. And we were actually talking about attaching a Treg cell on the edge of that probe and measuring the affinity of the receptor junction between that cell and a cytotoxic T cell, which is, I think, a relatively new type of project. Yeah, so that would be where that comes into play.
Okay, I actually do have a question. So in a little schematic you showed the U.S. It was split in half with the North and the South, like kind of thing. But there were exponentially more cases of MS in the North. Do you have a reason why that might be?
She's asking whether the North, or why the North would have more MS. I'm actually not too sure. The only thing that I can think about is that it has to do with the environment, and something's causing issues with the immune system, or like it's causing defects with the immune system in the North. That's maybe different to the South.
And elaborating on that idea from the trends we studied, essentially, like, since much of the northern United States lie on the same latitudes as Europe, the like northern part of the world, Europe, North America, these areas have a substantially higher risk of multiple sclerosis.
Gentlemen, this is very interesting. Clearly, this is a huge impact on people, and over 1 million people. Is it possible that the differential between the hemispheres is perhaps population based? But the question I have for you is are you saying by looking at the actual junction that where the Tregs join onto the nerves, that by looking at that, that is how you do assume that that is where the problem of the breakdown of the myelin is? By looking at that, you can actually tell that from the microscope?
Okay, so his question was whether looking at like the actual junction between the T cells is the reason for multiple sclerosis and causing cytotoxic T cells to degrade the myelin. I think that's what you're asking. So, well, multiple sclerosis there's no cause for it, and that's likely due to there being many reasons for this issue. But we kind of are trying to narrow that down to maybe a specific set of cases where there are there's issues with T cell interactions. So we were thinking we would determine Treg cells calm down the immune response. So we were seeing if there was an issue with those Treg cells calming down the immune response, whether there's low levels or so they can't calm down the immune response. And the junction between the Treg cells and the cytotoxic T cells, it calms the cytotoxic T cells down. So we were thinking that's maybe our solution. And the issue with multiple sclerosis is that the cytotoxic T cells degrade the myelin on the neurons. So maybe they're like, they have too much of a response, and they're doing that like really frequently, and that's causing multiple sclerosis. And maybe this could be like the location or the origin of the issue for some patients.
So not really a question, more of a comment. This is great. Like, hypothesis-driven project, right? You have an idea. You've very thoughtfully designed experiments using multiple modalities. Both you learned about in this class and outside of it, right? To explore a question that is unanswered, right? I know that obviously you have lots of references. There must be some, I would assume, indication that these interactions are implicated in this disease at some level. But I just want to say, in terms of all the groups, like, this is the type of project and the type of rigor that we like to see, right? A lot of it is not just saying we are going to use a microscope to look at this, but the question is why? What is the question that you're trying to answer, right? And that hypothesis you have about these interactions between these two types of T cells is a really inspiring thing to see from a group of young people, right? To come up with an idea like that, whether it's inspired from the literature or not, but then really delving deeply into it. I sure we'll see great ideas from everybody else, but for all the groups that follow, right, they did a fantastic job using hypothesis-driven science, right, as a mechanism for discovery. So I just want to say really good job to you guys. And
Thank you so much.
Thank you.
That's cool.